Well, good evening, everyone, and welcome to Meet Touchstone Essentials Live Training Edition. This is a wonderful night. We've got a wonderful topic, and Cindy Clement is here with me. Cindy, as you know, has a master's degree in nutrition. She is an expert in nutrition and is an master herbalist, adjunct professor. You name it, she's done it over the course of about 40 years, I think, Cindy. In this field. She teaches the doctors about nutrition. She's an absolute expert and a wonderful pleasure and a joy to work with. Please welcome Cindy Clement.
Thank you, Craig, and my whole Touchstone Essentials family. I love this opportunity, folks, to share my passion for education with you all. And I just want to mention that tonight's presentation marks 1 year ago that we started doing these. So we've done 28 webinars together, and I'm so honored. So again, thank you so much, everybody. Our product education this evening is going to focus on prebiotics, probiotics, and the gut microbiome. So I love this picture, Craig. It's awesome. I really like this.
Isn't it awesome? It really is.
I like that. Because it kind of goes with what I'm going to tell you about, which is our intestinal microbiome. It houses approximately 1 trillion microorganisms, and depending on your health, it can be anywhere from about 300 to about 6,000 distinct bacterial species. And it contributes to about 4 to 5 pounds of weight to our bodies, which is why if you get the intestinal flu or diarrhea, you can lose so much weight all at once. It's pretty much when you clean out that colon, you're losing that 4 to 5 pounds of that bacteria. But I want to go back to the beginning, the very beginning, about 460 to 370 BC, when Hippocrates was around. And what he said was all disease begins in the gut. Now, in modern times, this gut microbiome has emerged as a real major influence in the health status of individuals. And it is a rapidly growing field of study, and it's really a very great interest to researchers. So I have access to practically every peer-reviewed journal there is in the world because I'm a professor at a local university here in Michigan. And I'm able to research just about anything. Well, when I did just a general research for the gut microbiome in the year 2000, there were 0 results. And yet last weekend when I checked, 22 years later, there are over 41,000 published studies on various topics regarding that gut microbiome. So it's a huge, huge field of study. So the question is where and how does our biome begin? Well, folks, it really does all begin in our mother's gut. And we have to ask the questions, was she on prescription medications? What was she eating? What was she drinking? Did she smoke? How much stress was she under? And which environmental toxicants was she exposed to? Because these can all be factors that influence the gut microbiome. So these studies that they've done report that the mother's microbial communities, it changes profoundly in her gut during pregnancy in order to support her delivery. And the evidence says that our first inoculation begins inside the womb, but that also that the meconium, that black, that first stool that infants have, that tarry stool, the meconium, as well as the placenta, the amniotic fluid, and the umbilical cord also have microbiome functioning. And then after that birth, or after being in the womb, that further inoculation occurs during a vaginal birth from the bacteria present in both the mother's vaginal tract as well as in her anus. So in a vaginal birth, the gut microbiome is colonized by bifidobacteria. by lactobacilli and something called bacteroidetes, which we're going to talk about in just a minute. And the infant's microbiome is really well established at about 1 month of age. That's if we've had this vaginal birth. Now, in a cesarean birth, the infant's gut biome resembles that found on the skin of their parents or their primary caregiver. And then they show what are called fewer bacteroidetes. And again, we're going to talk about that in just a minute. So skin to skin is very important. My last grandchild was born C-section, and I remember that the doctors suggested that neither the mom nor the father wear anything on top and constantly have the baby's face on their skin in order to further inoculate her, which I thought was fascinating. Now, if that child is breastfed, more bacteria on the skin of the nipple as well as the colostrum, that helps to increase the complexity of the infant's microbiome. And it's also involved in shaping the composition of the gut when we become adults. Now, close physical contact with humans, yes, but also with animals facilitates that exchange of microbes. And so what we know is that children that are raised in homes with dogs, it seems to alter their gut microbiome to be more protective against respiratory viruses. So I just love that. Breastfed babies show a higher abundance and a more diverse. So what we want is we want this diverse microbiota. So remember I said there's anywhere from 300 to 6,000 different species. We want it to be as diverse and complex as it can get. So these breastfed babies, of course, have that more diverse community than do the formula fed. Now, the earliest of our gut microbiome consists of bacteria that metabolizes the lactose from the breast milk or from the infant formulas made from cow's milk. So that's that initial microbiome in the infant. And then when solid food is introduced, that gut increases other bacterial species that will assist that body's ability to use and digest protein, carbohydrates, and fats. Now, the infant's gut will begin to resemble an adult microbiome when they're about 3 years old. But until that gut develops in that child and it stabilizes, it's really vulnerable to infections as well as antibiotics or steroid use. Now, of course, antibiotics can save lives, but when they're used indiscriminately, they not only cause disruption, but they may, and this is what the research shows, even result in a permanent shift in the gut microbiome that increases their risk of future childhood obesity. So this gut microbiome is just so fascinating. That's why the researchers love it so much. So also, colonization as an infant is imperative to help increase the production of those feel-good neurotransmitters that will help the child in their response to stress as they grow older. So that's all with the kids. Let's talk about what happens in the aging process. Now, what happens as we age, just as with everything else in our body, it undergoes these substantial changes, and it can affect our immune system because we know we have that gut immune system, but it can also result in a greater susceptibility to infections. There can be a decline in the conditions of the teeth from the gut microbiome aging, or salivary functioning. It can affect your digestibility or the transit time of the stool moving through the intestines. It can lead to a real significant reduction in that diversity of the microbiome composition. And then when that happens, of course, we could experience increased inflammation, high frailty changes and things like that. We'll have changes in sleep and in mood in the elderly, as well as diabetes or fecal incontinence or even cardiovascular disease. So the gut is just so important. And most of us are aware of the effect that a decline in digestion will have on the gut and on the transit time. But as you can see, this reduction in the composition and the diversity really does lead to a whole host of health concerns. And so it's just, again, it's a lifelong of really taking care of the gut, making sure you have those probiotics and prebiotics. Now, back to that fetal development. When that infant, when the fetus is in the womb, the brain and gut, which I think is so fascinating, the brain and gut both develop from the same tissue. And one part of that tissue becomes that enteric nervous system, enteric meaning intestine. So it becomes our intestinal brain, if you will. And then the other half of that tissue develops into the central nervous system, so the brain and spinal cord. And so we have this brain gut axis, as I've mentioned before, which is that bi-directional communication system between the gastrointestinal tract and the brain and spinal cord. And this enables both that bottom up signaling from the gut to the brain, as well as that top down signaling, whereby the brain can influence both the secretory and the motor function of the gastrointestinal tract. Now, stress and anxiety have long been known to negatively affect negatively affect the composition of the gut. And again, that's known as the top-down signaling. So for instance, the gut itself can have a significant influence on the psychosis, mood, and behavior. And so what we know is that each of them they're kind of connected through that vagus nerve. So we've got to keep the health of the brain and the gut both in check. And the research shows that exposure to stressful events influences that composition of the microbiome, and it can create both short-term and long-term effects. So as I mentioned, the stress can influence the gut motility and secretory functioning, but when the gut is a mess, it can induce depression and anxiety and that bottom up signaling. But the good news is that these probiotic strains can alleviate some of that psychological distress. So when they did this research with laboratory animals, they exposed them to what they call social disruption, and it resulted in an increase in inflammatory markers, as well as reduced the lactobacilli, which is that one of the healthy bacterias. And what we know in humans is that this imbalance in that intestinal bacteria has been implicated in diabetes, in metabolic syndrome, obesity, as well as cardiovascular disease. The overgrowth of bad bacteria in obese patients is also linked to non-alcoholic fatty liver disease. So all of these things appear to play this role in our health, which is again why the gut is just so important. The changes in that bacterial composition and diversity have also been associated with inflammation of the visceral fat tissue. And the visceral fat is the fat that grows around the organ areas. It's not the fat that accumulates, on our body, but the visceral fat is very different. And when we have inflammation of that visceral fat, it can play a strong role in the development of what we call cardiometabolic disorders, like having our good cholesterol too low and our bad cholesterol too high, or that insulin resistance where the insulin cannot get into the cells to help with the glucose transfer. And it can also increase our risk of cardiovascular disease. So other things that can happen when the gut isn't happy is that leaky gut. And that's when that inflammation increases that intestinal permeability. So again, I'm going to go like this, and these are the tight junctions. The lining of our intestines has what we call tight junctions. And what happens with inflammation is it increases, and of course that's microscopic, but it increases that permeability, and it disrupts that tight junction and creates what we call that leaky gut. And then the bacteria from that gut leaks beyond that mucosal barrier, and it's just like this vicious cycle, and it continues to weaken those tight junctions. So we know about the bacteria, in the vagina and the skin, and consider kissing that infant as well. And then we're sharing even more bacteria. But I love this chart. I think this is such a fascinating chart on the different colonies that are found in the different areas of our body. So again, this colonized bacteria not only lives in the gut, but it's in our nasal passages, it's in our oral cavity, it's on our skin, in the ear canals, it's on our reproductive organs, it's in our stomach, our esophagus. And what I want you to note is how the colonies of different bacteria change depending on where it's located in the body. So no wonder scientists and researchers are mesmerized by the microbiome. Although I will tell you that the endocannabinoid system is really a close second. They've had over 12,000 published studies on the ECS over the past 10 years. Now, what we know is there are about 50 plus bacterial groups that have been detected in that gut microbiome to date, but the two major families are something called Bacteroidetes and Firmicutes, and they represent about 90% of the total community in our gut. So the Bacteroidetes, huge family, lots of different species in that family, lots of different species in the Firmicutes. But I mentioned before that in a cesarean birth, that the infant's microbiota has fewer Bacteroidetes present. Now, Bacteroidetes are believed to be involved in that barrier integrity, as well as in our brain and nervous system health and our immune health. And what the Bacteroidetes do is they digest carbohydrates, and they play a major role in sustaining what we call the microbial food web in the gut. And what researchers have observed is that, and I think this is interesting, when you have a higher ratio of Firmicutes to Bacteroidetes in obese humans, while there is more Bacteroidetes and less Firmicutes in the leaner people. So the research of a couple of, I'd probably say about 10 years ago now, what they were doing in research is they were doing fecal transplants with laboratory animals. And they would take twins of mice that were twins, and they, through feces, through fecal transplants, they put the wrong bacteria, the Firmicutes, into these identical twin mice. And the one that had the overabundance of Firmicutes got very obese. And when they had the more Bacteroidetes in the exact twin, he or she stayed lean. So what they did then is they did this fecal transplant, and they put the Bacteroidetes back into this laboratory animal, and it slimmed down. So they have been doing things like that at Johns Hopkins Hospital with people that have been chronically obese. So it's just, and they do it a lot more in Europe than we do in the US. But don't get me wrong, the Firmicutes are also beneficial when they're in balance with those Bacteroidetes, because Firmicutes also play a significant role in the relationship between the gut bacteria and our health, because they too break down carbohydrates in the gut that can't be digested by the body's enzymes, such as things like fiber or that resistant starch. Both Firmicutes and Bacteroidetes are responsible for carbohydrate metabolism, but they also participate in energy production and conversion in our body, in the transport of amino acids, our metabolism, and things like that. So it's just really fascinating. So now that we understand a little bit about that microbiome, I want to look at ways that we can support it. So again, a greater diversity of helpful bacteria is found when the diet is primarily plant foods and plant protein, which is what Touchstone Essentials products are all about. But additionally, fiber-rich diets have been shown to increase this healthy bacteria and then improve that gut barrier, increase that insulin sensitivity so it can get into the cell, as well as normalize those lipid profiles. So in other words, get our good cholesterol back up and have more, or I'm sorry, have less of that, of what's considered the bad cholesterol. But in this process, we also have to consider eliminating the things that negatively affect our health, like exposure to environmental chemicals and pollutants, or having too much of that visceral fat wrapped around our organs, or accumulated waste in the colon, or an overabundance of foods and beverages that are, promote an inflammatory response in the body. So again, this adherence to a plant-based diet has demonstrated over and over again the advantages to our physical health when compared to that typical Western style diet, which is refined and processed and fried and sugared up. You know what I mean? So it's important, it's imperative that we restore, we not only adhere to that plant-based diet and get out the things that are undermining our health, but we need to restore that healthy balance of beneficial bacteria to the gut by re-inoculating with that desirable GI flora. And then to get our body working at a more optimal level, especially after taking antibiotics or steroids and things like that. But let's just take a step back for a moment to understand what happened in our knowledge of probiotics. There was a fellow by the name of Eli Metchnikoff, and he won a Nobel Peace Prize in 1908. And why he got that prize was he increased the longevity of peasant Bulgarian farmers who were living in poverty and a very harsh environment. And how he did that, how he increased their longevity, is through the use of probiotic rich fermented milk products. And in this act, it resulted in them, in these peasant farmers, outliving wealthier Europeans. So I mean, it was a pretty interesting thing, but the discovery of penicillin just 20 years later turned the attention away from seeding the gut with healthy bacteria to the practice of killing bacteria. So as you know, an antibiotic, antibio, is against life. And so what it does is it sweeps all of the bacteria out of your gut, good and bad. So of course, later antibiotic use really became a major public health threat with when that spread of resistant bacteria began to flourish and certain infections are no longer responding. Now, the World Health Organization defines a probiotic as a live organism which, when administered in adequate amounts, confer a health benefit to the host. So probiotics survive the stomach acid and bile, and they adhere to the lining of the intestine. They've been shown to inhibit the invasion of pathogens, improve the gut barrier function, and reduce those intestinal endotoxin levels. And endotoxemia, or an endotoxin, occurs when the cell wall of these bacteria containing compounds leak into the blood, and this results in what we call systemic inflammation. And this can increase our risk to depression and muscle pain and fatty liver disease and just a number of things. But probiotic supplementation has been shown to lower the frequencies of so many of these things. It's anti-inflammatory. It has a positive effect on the cells lining not only the gut, but the lining of the walls of the blood vessels. So when we increase these health promoting bacteria like lactobacilli or bifidobacteria, there's a shift in the gut's microbiota balance, and it increases these bacteroidetes abundance in the gut. So, as an added benefit, probiotics can even have an appetite decreasing effect for those of you who are interested in that. So, where do we get these probiotics? Well, first of all, super green juice provides 4 different types of beneficial probiotic bacteria with approximately 1 billion colony forming units in a serving. And the 4 different types, we're going to take a look at each one of them, are Bacillus coagulans, Bifidobacterium bifidum, Bifidobacterium longum, and Lactobacillus gasseri. Now, super green juice contains not only these 4 strains of probiotics, but it also has fiber and digestive enzymes that are also going to help restore that delicate balance of the microbes in our gut. They're going to help to support our digestion and keep that bad bacteria in check. So let's look at the Bacillus coagulans first. The clinical research shows that by taking Bacillus coagulans daily for just 2 to 3 months can improve the quality of life by decreasing bloating, nausea, vomiting, abdominal pain, as well as the number of bowel movements in people who have what's called diarrhea predominant irritable bowel syndrome. Now, Bifidobacterium bifidum, which they usually say B period bifidum, is one of the most common probiotic bacteria that can be found in the body of all mammals, including humans. And several high quality studies suggest that this particular strain shows promise in treating H. pylori infections, irritable bowel syndrome, constipation, lung infections, ulcerative colitis, and even certain kinds of diarrhea. Now, in clinical trials with Bifidobacterium longum, it demonstrated that it counters the effect of obesity. It can offer protection against inflammatory bowel disease by reducing that intestinal inflammation. And it's also effective in alleviating infectious diseases by boosting our immune system. And then the last one, Lactobacillus gasseri, is a normal inhabitant of the lower reproductive tract in women, but it's also been shown to aid in weight loss, bowel problems, as well as with ulcers. Now, Super Greens Plus D includes over 5 billion colony forming units per serving. So your gut is continuously replenished with these beneficial bacteria. It too also contains these plant-based enzymes, and it also has the prebiotic inulin, and that helps to strengthen the gut microbiome. Now, inulin is it's a starchy substance that's found in a wide variety of plants like fruits and vegetables and herbs and things like that. And inulin is not digested or absorbed in the stomach. It stays in the bowel, and it helps certain beneficial bacteria to grow. So prebiotics, they're pretty much let's call it a specialized non-digestible fiber that ferments in the gastrointestinal tract. And what it does is it kind of like acts as a fertilizer. And what that does is it stimulates the growth of probiotics, of the beneficial bacteria in our body. So think of the prebiotics as just a food for our body to make, for our guts to make its own probiotics. So fermented vegetables and prebiotic containing foods have been shown in clinical studies to not only reduce blood pressure and heart rate and cholesterol, but induce weight loss and decrease those toxin producing bacteria. The research has also suggested that prebiotics can reduce our risk of type 2 diabetes and osteoporosis. So this is just fascinating stuff. Now, Prebiotics can also reduce that gut permeability and that inflammation. It can reestablish those tight junctions at in the intestine, reduce the toxins in the gut. And they've also shown promise in helping people with non-alcoholic fatty liver disease. Now, inulin is one of the most studied and most commonly consumed prebiotic supplements. And inulin type prebiotics, again, enhance that growth of both bifidobacteria and lactobacillus in the gut. And again, have shown improvement in that glucose management, that insulin and glucose, reduction in fat mass, and inflammation. So Jerusalem artichoke contains inulin, and it helps to increase that friendly bacteria in your colon, promote that greater digestive health. It can also aid in the absorption of the minerals in our large intestine. And flax seeds are also a great source of prebiotics, and they promote that healthy gut bacteria as well. They encourage that regular bowel movement, and flax seeds also reduce the amount of dietary fat that you digest and absorb. So where can we get these prebiotics? Jerusalem artichoke is found in essentials. It's in Super Greens Plus D and Super Green Juice. The mushrooms are found in Super Green Juice, Super Greens Plus D, and Essentials. And flax seeds are found in Organic Super Protein and Wellspring and Super Green Juice. So keeping a healthy gut microbiome, it's going to be involved getting enough protein and plant food choices, again, versus those simple carbohydrates in that Western diet. And this is interesting. In shaping our gut microbiota from both birth to adulthood, it is the diversity is due to what we eat. And there's this perfect example. The Japanese gut microbiota has this special seaweed associated marine bacteria that is not found in other people. They call them the nori genes, and they evolved with their feeding habit. So we need good foods because we really are what we eat. Approximately 50 to 85% of seaweed's fiber content comes from soluble fiber. And again, that nourishes the cells of your gut. So remember that greater diversity of helpful bacteria is found when we have primarily plant foods and plant protein. And folks, protein is that major functional and structural component of all of the cells in our body. And those proteins are what develop those tight junctions, and they reduce that leaky gut, that permeability. So by increasing those health promoting bacteria, like in the lactobacillus family and the bifidobacteria family, that shift in the gut occurs, and it increases all that good stuff in our gut. And also, while we're on the topic of the gut, let's not forget that fulvic acid and these minerals also support gut health. Fulvic acid can strengthen our immune function. It can boost our nutrient absorption. It can optimize our cellular function. It can improve our energy level, support our brain health, fight free radicals, and even support detoxification. And I'm so excited that next month we are going to be presenting a webinar on fulvic acid and the minerals. So watch for that, okay? So in closing, there is a microbiologist at the California Institute of Technology. His name is Sarkis Mazmanian, and he says the importance of the gut microbiome balance is like a garden, and that you're less likely to have weeds growing, bad stuff in your gut, if you have lush vegetation, all that good bacteria. But without that vegetation, that good bacteria, the weeds, the bad stuff can potentially take over. So keep that in mind, folks. And that concludes tonight's presentation. Please mark your calendars to join us next Thursday on June 2nd, and we're going to talk about plant compounds. We're constantly talking about things like phytonutrients and phytochemicals and all that good stuff, and we're going to explain it so you know exactly what it all means. So back to you, Craig.
Exciting stuff, Cindy. Thank you. The gut microbiome is just absolutely fascinating. And now we've got one more tool in the Fulvic Minerals Plus that we're excited about. Was just introduced last night and this morning with our newsletter that went out. We're excited that we're going to be talking about that in a couple of weeks. Is it on the 16th? Trying to remember the exact date.
Let me look.
Yeah, I think it's on the 16th. So we're talking about plant compounds. And then on the 16th of June, we'll be talking about Fulvic Minerals Plus, and we're going to do a deep dive into that. So you'll want to join us for that special webinar. So thank you, Cindy. We appreciate you as always. And ladies and gentlemen, thank you for being here tonight. We'll see you soon.
Happy Memorial Day.
Bye-bye.